In this video, we'll be discussing translation in the PGIS environment. It's a method of moving shapes without actually altering the command's coordinates. So let's jump into this. When you create a program here on Khan Academy using Processing.js, the output is drawn to a canvas that acts like a piece of graph paper. To draw a shape, you specify its coordinates onto that graph. As an example, here's a simple rectangle drawn with the code rect 60, 60, 40, 40. If you want to move the rectangle 80 units right and 100 units down, you can just change the coordinates by adding to the x and y starting points, like so. And the rectangle will appear in a different place now. But there's a more interesting way to do it. We could actually move the graph paper instead. If you move the graph paper 80 units right and 100 units down, you will actually get the same visual result. Moving the coordinate system is called translation. The important thing to remember is that, as far as the rectangle is concerned, it hasn't moved at all. Its upper left corner is still going to be at 60, 60. When you use transformations, the things you draw never change position. The coordinate system does. So I'm going to set these values back to 60 for the x and y. And below here, I'm going to define a new rectangle. It's going to be red, but we're going to give it an alpha value of 128. What this does is it actually draws the rectangle with a half transparent effect so that you can kind of see through it. So I'm going to set this at 60, but use our method of adding the values to it. So just like that, set its width and height. There we go. And as you can see, that red color isn't entirely red because we're using the alpha there. And underneath this, we're going to make another rectangle, fill that with a blue color here. But we're also going to give that a alpha value because we want this to also be somewhat transparent. And underneath here, we're actually going to use the translate now. We're going to really do this just to show you how they kind of compare. So push matrix is a pretty interesting function. We're going to discuss that in just a moment. But you got to use them because they're really helpful, and they also kind of separate this translate from the rest of the code. So we're going to translate this rectangle 80 and 100, and we're just going to go ahead and draw the rectangle in the original position, and we're going to see what happens. There we go. As you can see, that blue rectangle actually just covered the red ones. So let's take a look at it. If I was to change this 80 and move it, let's say like 65, you can see that they overlap each other, and red and blue make purple, so that's kind of cool. But yeah, we can use translate to move a rectangle just like we would with these values up here. Now let's take a look at this translation code. Push matrix is a built-in function that saves the current position of the coordinate system. The translate 80, 100 moves the coordinate system 80 units right and 100 units down. The rect 60, 60, 40, 40 draws the rectangle at the same place it was originally. Remember, the things you draw don't move, the grid moves instead. Finally, pop matrix just restores the coordinate system to the way it was before you did the translation. But why use push matrix and pop matrix? You could have done a translate -80, -100 to move the grid back to its original position. However, when you start doing more sophisticated operations with the coordinate system, it's easier to use push matrix and pop matrix to save and restore the status rather than having to undo all the operations, because sometimes you can get several operations going at once, and it'd be annoying to have to undo them all. Later on in this section, you will also find out why those functions seem to have such strange names. You may be thinking that picking up the coordinate system and moving it is a lot more trouble than just adding to the coordinates. For a simple example like the rectangle, you would be correct. But let's take an example of where translate can make life a lot easier. So I'm going to copy and paste some code into this program to kind of help us visualize this. There we go. This is a program that draws a row of houses. It uses a loop to call a function named drawHouse, which takes the x and y location of the house's upper left corner as its parameters. Notice that the drawHouse function has to do a lot of parameter manipulation to get the house drawn at the given coordinates. But what if we use the translate function instead of calculating new coordinates with all these variables? In this case, the code draws the house in the same place every time. So let's replace all this with a push matrix block of code, I like to call it, so that it's separated from the rest of it, and translate the house by the x and y coordinates. And in here, we'll go ahead and draw the house. It's going to be at 15, 0, 0, 15, 30, 15. We're going to give it the body of the house, 0, 15, 30, 30. And then the doorway, 12, 30, 10, 15. All right, looks pretty good. Now, as you can see, we actually just used translate, and it seemed to have simplified this code a lot more. We don't have to use the variables like we did before. Now, this doesn't mean that you should always favor translate instead of calculating new coordinates, but like much of what we teach, it's just another tool in your toolbox. And it will be up to you to figure out when it makes sense to use this new translate tool. Hope you enjoyed. See you in the next video.